So I do the force diagram. So right away, do my F sub n, I have my T, I have my F sub G, and I have my F sub F. T, of course, gets broken into Tx, Ty. This F2G, or I guess I could just FBG, I guess, since it's mass. Is this mass B? Yeah. Yeah. And then this is just T. So, one thing I can see is the sum of the forces in the Y are 0 for B, right? Because there's no A, so I get T is equal to FBG, which is, oh, sorry, just kidding. I should say like that. And that means T is equal to MB times G. Then over here, sum of the forces in the X are equal to 0. So from that, I get F sub F is equal to Tx, or I get mu F sub n is equal to T, and I believe this angle right there is 30 degrees, so that means that's theta. So I get T something like sine theta. And then the sum of the forces in the Y are 0. So I get Fn plus T cosine theta is equal to M sub A times G. Find FF or mu. Oh, Fn, okay, sure. Okay, sure. Let's see, what's the easiest way to do this? Did they give us mu?
They gave us an
No, did they give us mu, the coefficient of friction? You know what, I'm gonna,
They gave us how much the two things weigh.
well, okay, so I'll just stick with this then. Fn, so I did this statement, but I'm just not gonna use it right now. So Fn is gonna be equal to M minus T cosine theta, and T is MBG, so I can do MBG theta. And so, yeah, I get G times minus MB times cosine of theta. What are the masses of these things?
A is 20
Kilograms, B is 3 kilograms, 5. And the cosine of 30 is 0.866. So this becomes 0.8 would be 2.4, 2.5. So then that's going to be 17 by 175. So 75. So 5 newtons. Yeah.
Did you change gravity
Did I change gravity to
to
mass
Y?
here?
Yeah.
No, this is the force of gravity on mass B. And then I turned that into mg. So I didn't turn the weight of an object into gravity. I said the weight of an object is mass times gravity. Does that make sense? Other questions? Yeah.
How do you got those numbers?
Where did they get those numbers? I don't know, people gave them to me. 10 is gravity, because I'm lazy and I want to do mental math. 20, I was told, that's A. Then mass B, I was told was 5. Is that right? Oh, I multiplied that wrong, sorry. If that's 5 times 0.866, I shouldn't have gotten that. I did 3 times 0.866. 5 times which should have been 4.3. And 4.3 from that would give you 15.4, so you get 154 newtons maybe? But, I mean, the numbers, blah, 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 I'm just doing it all in my head, it doesn't matter. I mean, you could plug them in and get the actual answer yourself. The key is, do you see all the logic? Do you see the physics involved here? The physics involved in this problem are these force vectors. Can you do the free body diagram? That's number one. Secondly, can you create the sum of the force statements from that free body diagram? That's the physics. The rest is algebra or trig.
What is
What does Fn mean?
I mean,
The number is this, 154.
oh,
Yeah, you're finding Fn. That was part A, right? What was part B? The force of friction? Frictional force? Okay, well that's cool. So we already have that up here, which is just gonna be T sine theta, which is gonna be 5, whatever, 5 times gravity. So that's times 10, times the sine of 30 degrees, which is 0.5. So then that's gonna give us 25 newtons. That looks like 125 newtons. So I guess we did use the top sort of, didn't have to find mu, but yeah. Yeah,
What exactly is mu?
well, you should have, we took notes on 4 and 5, did we not? Okay, so you tell me, what's mu? You should have this definition. Now, I'm asking you for the definition, and then I'm gonna talk about it. So, I'm not just trying to answer your question with a question, but I'm trying to enable you to see that you have the answers yourself. So what is mu? Wow, so from nobody's notes, did they record mu? Yeah, this is very important. So Sarah's question is a very important one. What is mu? Mu is the coefficient of friction. I don't know if that's 1F or 2, or whatever. Coefficient of
It's 2.
friction. Now, what does the word coefficient mean?
It's in front of the number.
Sorry?
It's in front of a variable.
Yeah, that's true. It's in front of a variable. Oh, that's why they call it that, because it's usually in front of the normal force. And equation that says mu is the ratio of the frictional force divided by the normal force. Actually, you had to do this. You had to use this for the lab. Right? Mu is this ratio. The ratio of how hard it is to move something versus its weight. So if we had 3 blocks, and all of the blocks are 1 kilogram, and this one is glass, this one is, I don't know, let's say stone, and this one is rubber. Which one will, what do you think will be harder to drag along the, well, let's not say stone, let's say wood. Which one do you think is gonna be hard to drag across the floor? Okay, because that's why we use rubber to make the bottom of our shoes, yes? Because rubber is sticky. Rubber has a high coefficient of friction. How do you make this number? Yeah, just look at what it equals, right? How do you make this mu bigger? Either the force of friction is bigger, meaning it's harder to drag that thing, or the weight of that object, the force, the normal force between it and the floor is lighter, right? Because if that gets lighter, this gets bigger for a given weight. So this is these things. Literally, if we had the 3 blocks sitting here on the table, and I took a spring scale, obviously F sub n should be those sitting on a table. Does everyone see that? Yes? No? Richard, does that make sense? Is it Richard? It's Ben, huh? What's your name? Anthony. Oh my God. I was hearing that. Sorry, Anthony. Anyways, go ahead. Anthony, why is it true the normal force will be the same? All 3 of those blocks sitting on a table, why is it true that the normal force will be the same for all of them? Because what? So does that mean any three things surface will have the same normal force? Do you know? Do you know?
Because
If they all have the same mass, right? And if they're just sitting on a table, an object just sitting on a table, you should make, in your mind, the force diagram for that thing. Normal force up, gravity down. That's it. So then the normal force should be the same for all of them. Whether this is a kilogram of lead, kilogram of feathers, kilogram of air, whatever, the normal force should be the same. Okay? Now, does it make sense to you that the frictional force, the force required to drag these along the will be different? Right? Which one's going to be the easiest? Probably. Probably the glass, because the bottom is perfectly smooth and hard. Then the wood might be second, because it's a little bit softer, so the ground will kind of bite into it more. You get more friction. And of course, the rubber will be the most, because it's going to mold to the ground and it'll be hardest to pull. So the frictional force is a function of how much it takes to drag across the floor. Why do we have this thing called mu? It's so that I can look at different materials and say, all right, I want to make something that sticks to the ground. I'll look up my table of mu, and which one should I use? Yeah, rubber. Does that make sense? Right? So mu is literally a laboratory result. It's the result of testing a bunch of times. I give you 3 different materials. You should be able to come up with mu for 3 different materials. You came up with mu for one, did you not? And would not your procedure fit just about any material? Right? You set it on there, you tilt it until it slides, and then lather, rinse, get your data. Does that make sense to everyone? So Sarah's question was, in short, mu is a ratio. Mu is a ratio. And it is the ratio of how hard it is to pull something, how hard that thing is pressing into the surface. So in general, it's how sticky it is. Yeah, like maybe, I don't know if it's a good way to think about it. Imagine, I don't know, let's say Stephanie, gets her new BRZ. In fact, she gets the BRZ STI a year earlier than everybody else, but it's 300 horsepower motor, right? And then, but she doesn't like the Michelin whatever on there, so she wants better tires. Tire store. And there's all these tires that fit her car. Right? How does she know which one is the best? Well, yeah, she could Google it, right? But maybe she doesn't trust that. So what is an experiment that she could do at the store to determine whether or not tire is stickier than another? Right? She's probably not going to get them to put them on her car and then go whipping. In fact, what we can do, Stephanie is obviously a drifter. She doesn't want the stickiest tires on the back. She actually wants some tires that are pretty sticky, so she can kick that rear end out with the throttle and make a nice drift. So what she can do, right, is take 3 tires. She has the 3 tires. And how would you measure how much force it takes to make them slide? How would you do that? How could you find out how much force it takes to make them slide? Right? How would you find mu for those 3 tires? Talk with the people in your group. Go.
I got to the point, well, right now I'm after Aaron discovered the time shift.
Oh yeah.
When I first saw him die, I'm like, that would completely defeat the purpose of the entire animation.
It would be interesting.
Yeah, that's like I would like to see how they would have picked it off, like how they would have picked it up after they never brought it back. It would be like,
Wait, what did he was
he pushed Armin out of the way. And then
yeah, but then how did he get out of it? How did
he he was inside.
Oh, he was inside and then he like popped out.
Yeah. And then like it was so easy to discover like the plot twist. Like Black Eyes has rudimentary fighting skills, is only Titan fighting other Titans. I wonder who it could be. That three-dimensional energy is pretty interesting.
Yeah. Makes no sense. All right, Ben. Where's Ben? Oh, there we go. Okay, Ben. What did your group come up with?
We could to test the force or the friction.
Mhm.
We would like turn the tire sideways,
Uh-huh.
and then we would push it and see how much friction.
And which of those things would you get from doing that? In that equation, yeah, are you going to get mu? Are you going to get FF? Or are you going to get FF?
We might get the force of friction.
Yeah, does that make sense to everyone? Okay, now, let's say that Devin gets a bonus because he works at the store, right? I don't know why, I just told you. But, and he gets a bonus if she buys the Goodyear tires. So what could Devin do that's sneaky that would make her think, because she thinks all the tires weigh the same, that would make her think that the Goodyear tires are stickier than the other ones? What could you do, Devin? Oh, these don't, they're not on anything. They're just naked tire. Sneaky. But you were right about the deflating though. That would work. Anyone else thoughts? Sticky. Sure, coat it with glue, yeah.
Make it weigh
She
less?
wouldn't notice that. What?
Make it weigh less?
Okay, so he can affect the weight of the tire. Now, remember what you're doing right now. Oh, this is recording this whole thing. If he affects the weight of the tire, then he's going to affect mu. Now, if she's recording mu, then yeah, he's going to want to shave some of the rubber off the tire, make it a little lighter, so it seems like it's going to be different. But does everybody kind of get this general idea now? Okay. All right, so that's mu. Sarah, does that answer your question? In a very extended and protracted fashion.